Where is the general organizer? So this is, of course, this presentation is, of course, not my own joy, but it's a group of persons and some specialists of soil physician and soil hydrologists. 14 years before, near the town of Marseille, from 70 kilometers from the west, we've got this terrible technological accident in a very beautiful place, which is called the Crow Plain, which is a unique steppe ecosystem of Western Europe. And this slide, it looks like for amateurs of comics, like Tintin in the land of gold black. But really, it's not funny, because it has destroyed more than 5 hectares of this unique ecosystem, which is protected by a nature reserve, and more than 5,000 cubic meters of crude oil are spilled over the soil surface and go deep in the soil and pollute also the groundwater and the water table. So it was a terrible, catastrophic event. And of course, it was decided to do the rehabilitation of this site by doing soil depollution, of course, and the solution which had been chosen is to take all the polluted soil, more than 72,000 tons of soil, and to put in a specialized treatment line fight. So we create a kind of very big hole in the center of this nature reserve, which can be accepted from the biological manager to conserve the flora, of course, and the fauna of this site. And for restore this area, it was decided to take some soil in another place, in a near quarry, from 4 kilometers from the oil spill site. And they decided to take all the soil, so again, more than 72,000 tons of soil, and to take this soil and put in the place where the polluted soil was exported. And of course, we decided to do that because the soil from the quarry has the same soil properties from geology and pedology and the same plant community. So it was a very original and perhaps the first time in the world when they decided not only to put the soil that was certainly present before the accident, the same type of soil, the same type of plant community, but they decided also not to mix all the soil. They decided to reconstruct the different soil layers in the good organization. So they don't mix all the soil. It was done in spring 2011, and they bring back the different layer of soil in the good order. So they decided, of course, to put in the soil surface the topsoil layer, which is the organic soil layer, the subsoil mineral layer, and the transition between the bedrock and the soil. So you can imagine that it was a considerable technical operation. And here you can have several views. Sorry, the view are not so good because I was hill in the plane. It was very difficult because we turned a lot. And you can see here the different operation. It was done in spring in a condition of with moisture climate to be sure that plants and seeds can germinate again. And this is another view of the site. And the idea was to try to do this operation because we are in the nature reserve with a lot of ecological requirements, and so we do this soil transfer in spring. We do direct translocation, no stocking pile of soil, with a ratio of 1:1, and as I noticed before, we respect the soil vertical organization. And in terms of experiment, we try to follow different techniques of soil transfer, different modality of soil transfer. Some soil transfer really close than the soil which surrounding the site of the accident, the undegraded soil steppe, and soil transfer when we try to economize some soil layer. So we've got this different soil transfer treatment. And this is a view at the end of the operation. You can see the different graduates with a different type of soil restoration. And this is a view in 2014, 3 years after soil transfer. So what was the main objective of our study? Of course, we expect that we are able to transfer and to reconstruct the soil in the good organization of the different layers. We will accelerate the reconstitution of the different soil properties, such as the hydraulic and physico-chemical properties of the soil. And our hypothesis was when we do that in the better condition as we can, and we do a lot of things, we will really speed up the process of restoring not only the plant community, but also all the functional properties, all the functional ecosystem services of the soil. And when we do that, in the short term, we will arrive to reconstruct the soil. And if we don't do that, if we take only some part of the different soil layer, we will have an impact on the long term, and the soil will be definitely different than the surrounding reference steppe soil. And so we've got some results, of course. Yes, it was right. When we compare all the different properties of the soil, especially of the topsoil, of the surface layer, we've got, after several years, no significant difference in terms of soil functioning, such as basal respiration, for example, which we could indicator of the function of the soil. There was no significant difference, but only for the topsoil layer of the organic part, which have been put on the surface layer. And if you take a look at all the other different parameters, physical and chemical parameters of this soil, we've got also some success, because the result of the soil, which has been totally transferred in the very good organization, was close to the steppe soil. So it was a good result, and the result was very different for the different over treatment when we don't reconstruct the vertical organization. But after several years, we can state that there is no clear evolution from 2011 to 2060. We've got no evolution from the soil to the steppe soil. So it was strange for us that we have no evolution to a steppe soil, as we do a really it was cost expensive, a lot of things for this result. And so we decide to have a look not only on the soil surface layer, but we decide to have a view of the global profile layer. And we see that even in the soil which have been really reconstructed in the good order, things are still different from the reference. We use airform activities. We lose some roots of perennial tussock plants across all the vertical organization. It seems that we have not the same level of moisture in the deep of the profile. So we decide to measure the different hydrological properties of this soil. And it was clear that even if we try to do a lot of things to recreate as the same as the reference, the result was quite different in terms of infiltration rates. It was the opposite. Here, the infiltration rates was slow in the topsoil layer of the reference steppe, and here it was high, and it was the opposite at the back in the deep. And we've got the same type of result when we consider the hydraulic conductivity. Again, the hydraulic conductivity of the steppe soil layer of the reference was quite close than all the other layers which have been transferred, even in a direct transfer, and even with no stocking rate. So to conclude, even if we try with a lot of technology to reconstruct a soil, to take a soil in apart and just to put in another place, which in our case has been impacted by a technological accident, it's not enough to follow the vegetation, the fauna, and so on. We have to take care about the different properties of the soil. And it is clear that even after 5 years, these properties are still different than the reference steppe. For us, it was not too really happy about this result, because you can imagine that this type of soil reconstruction costs a lot. The total reconstruction of a site has cost more than 15 million euros, the depollution and the reconstruction of the soil. And it seems that now the difference in ecological functioning can explain by difference of soil texture, by lower level of organic matter, and reduced biological activity for earthworms. So now we will try to continue to follow these different parameters, and perhaps these different parameters will explain why we still have some different kind of vegetation from the site which have been restored in comparison with the reference steppe. So we've got several publications for more information, and I think I'm on time.
Okay. Thank you. Thank you.